This is lesson 12.4. It's called Representing Algebraic Relationships, okay? So let's talk about what an algebraic relationship is, okay? An algebraic, that's how you say that. Algebraic means having to do with algebra. An algebraic relationship is a relationship between x and y, okay? It's basically the relationship between x and y in an equation or in a table, in a graph. That is an algebraic relationship. And so far, we can determine if the relationship is additive or multiplicative. Okay, those are the two relationships you know how to find so far, okay? Algebraic relationships can be represented 4 different ways. You can see the relationship in a table. You can represent the relationship on a graph. You can represent the relationship as an equation. And you can write a description of the relationship, okay? Sometimes this is called the rule of 4, okay? Because you have 1, 2, 3, 4 ways to represent the algebraic relationship. So it's called the rule of 4. If you have one of the representations, you can find the other 3, okay? So if you have a graph, you can make a table, which means you can make an equation, which means you can write a description. If you have a description, you can do a table and a graph and an equation, right? So if you have one of them, if you have one of the 3, you can make the other 3, okay? If you have one of these 4, table, a graph, an equation, or a description, if you have one of those, you can then make the other 3, okay? So let's do that. In this case, we start with a description, okay? So it says, Therese pays to get inside the museum. After she walks around the museum, she wants to buy souvenirs at the gift shop for her friends back home. Each gift costs $5. The graph shows the relationship between the amount she spends on gifts and the total amount she spends in total that day at the museum. Use the graph to fill in the table and to write an equation. So we have a description and a graph. We're going to use the graph to make the table and the equation, okay? So the graph has x is 0, y is 4. 2, 4, 5. X is 0, y is 5. The y-axis is going up by 2s, 2, 4, and that right in the middle is 5, right? And then that's 6, 7, 8. So there's numbers in between that aren't marked. So that's 2, 4, 5. So x is 0, y is 5. X is 5, y is 10. 2, 4, 5. No, that's 6. So 5 is here. 2, 4, 6, 8, 10. So now when x is 10, what is y? 2, 4, 6, 8, 10. Y is right there, which is, that's 12, 14. It's going to be 15 because it's right in the middle. So that's 15. When x is 15, so that's 16. So 15 is right in here. Wait, so, oh no, 15 is in the middle. So it's 12, 14, 15 right there. So that means when x is 15, y is 20. Let's fill in one more when x is 20 because we have one right there. X is 20. See it? Then y is, that's 24, so that must be 25. So x is 20, y is right between the 24 and the 26, which is 25. All right, so what do we have here? Here's what we have. As x, oops. So we have 0, 5, 10, 15, 20. Then we have 5, 10, 15, 20, 25. So as x increases by 5, 0, 5, 10, 15, 20, then y also increases by 5, right? So 5, 10, 15, 20, 25. Basically, it's not multiplicative because if it was 0 times 5, 0 times 5 is 0. So basically you're adding 5 every time, right? 0 plus 5 is 5. 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20, and 20 plus 5 is 25. So it's an additive relationship. Okay? So we can write an equation because every time y is x plus 5. Okay? So it's an additive relationship because as x increases by 5, y also increases by 5. That's additive. Okay? 0 plus 5 is 5. 5 plus 5 is 10, and so on. So for every x value, you add 5 and you get y. So that is the rule of 4. You have a description, you have a graph, a table, and an equation. So here's the rule of 4. Description 1, graph 2, table 3, and equation 4. Okay? You can represent an algebraic relationship in 4 different ways. So let's move on to page 2 of the notes, where we are going to make a table and a graph from an equation, starting with an equation. The last time, the example I just gave you, we started with a description and a graph. Now we're going to start with an equation, okay? So an ordered pair, x and y, that make an equation true is called a solution of the equation. So when you have an ordered pair that works for the equation, that ordered pair is a solution. The graph of an equation is all the ordered pairs that are solutions. So the graph is every ordered pair that works in the equation, x and y values that work in the equation, okay? So what we're going to do is graph an equation. So right here, we have an equation y equals x plus 1. Here are the steps on what you need to do to take an equation and then make a table and then a graph, and then we're going to write a description, okay? So we start with the equation this time. Step number 1 is choose some values for x. Like literally just choose some values and then use the equation to find the corresponding y value. So let me show you what I mean. I'm going to start with x is 0. And then I'm going to plug 0 in for x in the equation. So 0 plus 1 equals 1. So when x is 0, y is 1. X is 0, y is 1. Okay, I'm going to choose another value for x. I'm just choosing some values for x. Let's do 1. When x is 1, I add 1. X plus 1 equals y. 1 plus 1 equals 2. So when x is 1, y is 2. And I'm going to keep going. I'm going to use 2. And then 2 plus 1 equals 3. So when x is 2, y is 3. I'm going to use 3. I'm just choosing these, right? I could choose any numbers I want, but I'm choosing 0, 1, 2, 3. When x is 3, I do x plus 1. Y is 4. So 3, 4. Okay. I'm going to now do 4. When x is 4, I add 1. 4 plus 1 is 5. When x is 4, y is 5. All right. So the next thing I can do is I can plot the ordered pairs from the table onto the graph, right? So let's do that. Now I have 0 and 1. 0 and 1. Then I have 1 and 2. The 1 is here. The 2 is here. Then I have 2 and 3. There's 2. 1, 2, 3. And I have 3. 1, 2, 3, 4. Then I have 4. 1, 2, 3, 4, 5. And the last step says draw a line to show all the solutions of the equations. So every ordered pair, if I draw a line that connects all of these dots right here, right? If I draw a line here, every ordered pair on this line is a solution to the equation x plus 1 equals y, okay? Y equals x plus 1. Every ordered pair on this line is a solution, okay? So that means right there, I could make ordered pair 1, 2, 3, 4, 5, and then it would be some decimal number, right? So let's see. 1, 2, 3, 4, 5. 1, 2, 3, and some, right? 3 and some decimal or some fraction. But all of those ordered pairs are solutions. So now let's write a description for this, okay? The description could be something like this, okay? Let's say it's an additive relationship. We can see that, right? We can see that you're adding 1 every time, right? X plus 1 equals Y, or Y equals X plus 1. So it's an additive relationship. So let's say, all right, let's say I'm going to do sit-ups every minute. Okay, I'm gonna see how many minutes I can last if I add a sit-up every minute. So when the timer starts, I'm going to do 1. And then at 1 minute, I'm going to do 2. And then at 2 minutes, I'm going to do 3. And then at 3 minutes, I'm going to do 4. So every minute, I'm going to do 1 more sit-up, right? So if the timer starts at 0, I do 1 sit-up. Then a minute later, when 1 minute has passed, I do 2. And then a minute later, when 2 minutes have passed, I do 3. And then a minute later, when 3 minutes have passed, I do 4, right? So that could be what's happening here. I'm adding a sit-up every minute. Okay, so we'll write that. Miss Smith is doing sit-ups. She starts the timer at 0 seconds or minutes and does 1 sit-up. Then she adds a sit-up every minute. Okay, so this shows you that when the timer starts, I do 1. 1 minute later, I do 2. 2 minutes later, I do 3 sit-ups. 3 minutes later, I do 4. 4 minutes later, I do 5. And the question is, how many minutes can I last, right? All right, that is, again, the rule of 4. This time we start with the equation. That's one representation. We use the equation to make the table. Then we use the table to make the graph. And then I thought about what possible situation could this describe and wrote a description. That is representation number 4. 4 ways to represent an algebraic relationship. And I actually put one more down here. Here's another example. We have the equation y equals 2x. That's a multiplicative relationship because I'm multiplying 2 times x. Here's the table. If x is 1, I do 2 times 1 and I get 2. If x is 2, I do 2 times 2 and get 4. And here's the graph. So this is a multiplicative relationship, right? So what's a possible situation for this? Let's say I'm going to give each of my students 2 pencils, okay? Each student gets 2 pencils. That means this x that is students, and how many pencils I need depends on how many students I have, right? So the students comes first, that's my independent variable, and depending on how many students I have, that is going to determine how many pencils I need. So this is going to be pencils. So if I have 5 students, I'm going to need 10 pencils, okay? So you have examples now of descriptions, tables, graphs, and equations for algebraic relationships. The rule of 4.